Okay, students, we're here with more biconditional statements practice. We are in phase 2. And it's just kind of nice because after all this notes, I think we will have a pretty good grasp, understanding on conditional statements, all the other forms, as well as biconditional statements. All right, so yay, let's get hyped up. Woo! All right, write the following statement as a biconditional. If two lines are perpendicular, then they form a right angle. So essentially, boom, I'm going to eliminate the if, I'm going to eliminate the then, and I'm going to put an if and only if right smack dab in the middle. All right, but let's make it look a little nicer. Two lines are perpendicular. I can write IFF, that means if and only if, but since I'm the teacher, I'm going to write if and only if. You can write IFF if you want. If and only if they form a right angle. Okay, a good old biconditional statement. So basically what this statement's saying is that two lines are perpendicular. If they intersect and they form a right angle, that's the definition. That's a really strong definition. All right, so there's that right there. All right, now we're going to recall, how do we determine if a biconditional is true or false? So we have this one right here. Two angles form a linear pair if and only if they are adjacent and supplementary. So remember, it has to be true in the conditional form. All right, so basically we're reading it the way it's written. If two angles form a, I'm going to put LP for linear pair, then they are adjacent and supplementary. Kind of keep running out of room, silly me. All right, and that's a true statement right there. All right, as you're writing that down, two angles form a linear pair, then they're adjacent and supplementary. I'm going to draw a picture down here. Well, for the linear pair, remember they share a side, and they add up to 180. So it's true. All right, but for a biconditional to be true, we also have to read it backwards, and it still has to be true. So I'm going to put it in its converse form. If two angles are adjacent and supplementary, then they form a linear pair. Again, I kind of ran out of room. If two angles are adjacent and supplementary, then they form a linear pair. Well, that also happens to be true. All right, so this biconditional that we read at the beginning, two angles form a linear pair if and only if they are adjacent and supplementary, that is true, because all forms are true, so the biconditional is true. Cool beans. All right, continue to practice. I go to Darby if and only if I live in Hilliard. All right, let's think about this one right here. Ooh, where'd all these colors come from? These are pretty cool colors. Let's pick this one. This one looks like toothpaste. Let's read it in its conditional form, and let's even practice putting it in its conditional form. If I go to Darby, then I live in Hilliard. All right, let's not overcomplicate this with boundary lines and city lines and all this fun stuff. Just taking that face value, this is true. If you go to Darby, then you live in Hilliard. All right, but what about in its converse form? We got to read it backwards. If I live in Hilliard, then I go to Darby. If I live in Hilliard, then I go to Darby. That is false. You could go to Bradley. You could go to Davidson. So those are counter examples. So therefore, this biconditional statement we read, I go to Darby if and only if I live in Hilliard, that is a false biconditional statement. It is not a strong definition. False. An animal is an alligator if and only if it has a lot of teeth. I love alligators. Whenever I'm down south, I go searching for them and I find them. All right, keep my distance from them, but I like finding them in the wild. Never wrestled them or anything like that. I should, though. I'd probably win. If an animal is an alligator, then it has a lot of teeth. That is true. Alligators have all kinds of teeth. And you know what's scarier than an alligator? If you have free time, Google alligator, Google crocodile. Crocodiles are significantly scarier than alligators, even though they almost look the same. All right, now we got to read it backwards. If an animal has a lot of teeth, then it is an alligator. That is false. There's a lot of animals with a lot of teeth. Probably the easiest one is the crocodilian. All right, here's a picture of a crocodile. We'll make it a smiling crocodile. He's happy. All right, so it's a false biconditional statement. So recall, for a biconditional to be true, the conditional and converse both must be true. Notice in the examples above, all the examples were true and valid math definitions. So basically it's just up here. These were true, valid math definitions. All right, those are really good stuff for math. This stuff was just fun examples about Hilliard and alligators. All right, stay tuned for more.